Hello everyone, today we're going to be talking about methods in Java. Imagine you're playing basketball and you want to shoot a 3-point shot. According to Stephen Curry, you have 4 steps to do this. Firstly, balance and foot position, then eye focus, then elbows bent, then the follow through and shoot. Imagine how to program this 3-point shot. If you're doing one 3-point shot only, it's reasonable to go step by step and do each step individually. However, imagine if you want to do 100 of these 3-point shots. Because each 3-point shot has the same 4 steps in the same order, thinking individually of each step will only waste time, effort, and energy. It's far more efficient for your brain to repeat the same steps as one action, rather than come up with the 4 steps again. So how can we repeat the same 4 steps when we want to perform a 3-point shot? We can use methods in Java. So what are methods? They're basically groups of statements that run when you call them to perform a specific task. There are 3 components: a method header, groups of statements, then the return statement. But there's no return statement if the return type is void, which is declared in the method header here, that also declares any modifiers, return types, the name, and parameters. Once you define or create a method, you can reuse it many times. For 3-point shots, we can use methods in the form of placing the 4 steps in one method, so the 4 steps repeats itself when the method is run. In methods, they can perform many actions that return a value or change variables. For 3-point shots, the method can return a Boolean value of true if the shot is successful, and false if it's not. The method can either return one value only, or not return anything, which is denoted by the keyword void. It cannot return 2 or more values. The method can also access and alter variables beyond the method, like static or instance variables. Here, this is the return type after the modifier and before the name. For methods, we can pass data into the method and it can be used inside the method when we call the method. For example, for 3-point shots, the position of the player will likely alter how the 3-point shot is performed. So taking in this data in the form of 2 doubles, X position and Y position, will be useful for calling the method and running the 3-point shot method. For parameters and return values, primitives will be copied to or from the method. Let's say that int w equals 1 and that max uses w to call. Say int w equals 1 and this w is used to call the max function as in here. Because of how 1 is a primitive integer type, it will be copied to the method. So if any changes happens to x here, it will not affect w in any way. However, for parameters and return values, only the reference of objects will be copied to and from. For example, in this example to the right, because y is an array object type, only its reference will be copied to the callR method as array. Both r and the y reference the same object, so as r changes, so would y. This means the method can alter the state of the object taken as parameter. In a class, each method must have a unique method signature, which consists of the method's name and a list of parameters. Java finds the correct method to run based on its method signature. All methods can share the same names, which is method overloading. The methods must have a different list of parameters to avoid ambiguity. Order matters, so int x double y will be different from double x int y. If 2 or more methods have the same method signature in the same class, there will be a compilation error because the program does not know which method to run. For example, in here, because of how, even though there are different return types, say max 1 2.0 is called, then which one will it run? Because both have the same name of max and the same parameter list. However, if we have the same parameters but different order, this problem can be resolved. For example, max 1 2.0 would run the first one, while max 2.01 would run the second one. So, summary. Methods are basically groups of statements that can be called collectively. They have a method header that declares the methods. They can perform many actions that return a value or change variables, can have data passed into them as parameters, which need to be defined when the method is called. The method in the same class must have a unique method signature of the name and the list of parameters, and the order of the list of parameters matters. Methods can accept any number of parameters but return at most one value. Primitives are copied to and from the method. The reference of objects are copied to and from the method. So how can we use methods? All modifiers are optional and changes the functionality of a method. One type of modifiers are access modifiers. These are placed at the very start of the method header and can change the accessibility of the method. For example, if the method has a modifier of public, it can be accessed everywhere in the world. However, it's protected. It cannot be accessed in the world but from its class, package, and subclass. Without any modifier for the access modifier, it can be accessed by its class and package. For private methods, it can only be accessed in its class. One important non-access modifier in AP is static, which means the method belongs to the class and not objects. It can access only static variables, which are variables that are the same throughout the class and all objects, and not any instance variables, which are different from object to object. Not having the static keyword means that the method belongs to objects and can access both static and instance variables. These methods must refer to instance objects of the class when called. So the parameter list is enclosed in curved brackets as in here. The comma separates each parameter, and the type of the parameter is always before the parameter's name in the method header. The formal parameters are the ones that are declared inside the method header, while the actual parameters are the values passed while calling the function. The parameters can be used inside the method by calling their names, i.e. exposition, and there's no need for the parameters type. If 2 plus parameters have the same name, there's a compilation error because it's ambiguous which parameter is being referred to. The return type is specified after the modifier and before the method name in the method header. The return type in the method header must agree with the return statement of the method. If the type in the method header is void, there's nothing returned, there's no need for a return statement. Once a value is returned from the method ends and stops running. If nothing is returned or void, all code until the closing braces is run. So how do we use methods? Well, we have common modifiers. You have a return type that must agree with the return value. You have a parameter list in closing brackets, and the order matters. We have formal parameters and actual parameters. All of this is summarized in this example here. To call a method, we need to use this method signature with its name and parameters. For example, method name and parameters. All the parameters are enclosed in the curved brackets, and each parameter is separated by a comma from each other. When the method is called, the parameters must be of the same order and type as specified by the method header. Otherwise, there will be a compilation error. For static methods, if it's called in the same class as the method, then nothing is needed to be added to the method signature as stated in the previous slide. However, if it's in a different class as a method, we must use a dot operator to access the static method. One method is to refer to the class name that the method is in, and another is to refer an instance object of the method's class. Method 1 is preferred as method 2 is redundant to refer to an instance object. It is also confusing as static methods will look like an instance method as a result of method 2. For instance methods as well as static modifier, regardless of class, they need to refer to an instance object of the method's class through the dot operator. For example, say cool number is of the class name class. So how do we obtain the value returned from the method? Well, we can initialize the variable equal to the method, as in here. An error would occur if this was attempted for void methods or if the initialized variable did not match the return type of the method. However, just calling a method without initializing a variable also works with an error. For example, in this example, no error would occur even though if whole number is not void. So what are the benefits of using methods? Well, firstly, less duplication of code for efficiency. As the code is only defined once, less time or memory is taken compared to retyping the code every time it's needed. This will make the program more efficient. For example, typing all the code for a 3-point shot separately every time it happens would take a long time, rather than simply using a method and reusing that. Secondly, there's better management of working with using methods. Using method decomposition, programmers can break down a larger problem into smaller subproblems by creating methods. Each method can solve each subproblem and allows tackling a larger problem systematically for efficiency. For example, when programming a basketball match, programmers can break it down to components like 3-point shots or layups, which will allow for tackling the problem in smaller parts easier to handle. 3. It reduces the complexity of code. Methods can break down the program into clearer, smaller steps, allowing for easier understanding of the code for other people. For example, it's easier to know that the 3-point shot is happening by calling its method rather than its 4 steps. 4. It allows access and control to private variables for other classes, enabling for encapsulation and data protection. As methods in a class can access or change private variables in that class, accessor and mutator methods can be called in from other classes if the methods are declared as non-private. Also, choosing to implement these methods or not will allow for control over access to these variables. For example, by not implementing a mutator method, a private variable in a class cannot be changed outside the class, which promotes encapsulation and data protection. Here are my image sources. Thank you for watching.